hear me?
Yes.
Okay, I will show my slide. Okay.
We see your screen. You're on presentation mode, however, if you want to switch.
Oh, okay. Okay.
Yeah, perfect.
Okay. I'm Xilong Zhou from Lenovo Research. I will present our work named Multi-Person Real-World Fusion Telepresence System. This is the agenda. And first, I will brief the background and motivations of our system, then show some new videos of our work, then introduce the components of our system and the pipeline of our system family. I will talk about the next step of our work. Looking at the evolution. Look at the evolution of the entire telecommunication technology industry. There are two core driving forces: the upgrading of the network and the advancement of the devices. Our communication experience have evolved from the one-dimension communication era, where only text and voice were possible. In this year, we could hear the voice but not see persons. Typing is the representative application in this year. Then we enter a two-dimension communication era. In this year, not only could we can hear each other, but we could also see each other. Now we are entering the 3D information communication era. Humans are the three-dimension beings that live within a four-dimension space-time. Only by upgrading to the three-dimension, the human can truly experience reality. Finally, we think we will enter the holographic information communication era. In this year, from visual experience, there will be no difference between the digital world and the physical world. Now, there are two types of devices that can be used to build the 3D communication system. One is VR and AR, which need to wear, and the naked eye 3D, which no need to wear. They both can let people feel 3D, but have different user experience. VR and AR will give person looking from inside out experience, and the naked eye 3D can give person looking through glass experience, which is more convenient for people to use it. Nowadays, there is two types of naked eye 3D displays that can be used to build the 3D meeting. One is the eye tracking based, one-person vision have a higher 3D resolution, and the non-eye tracking light field display, which support multi-person viewing but have lower resolution. We build our system based on the two types of displays. This is the first demo, and this is our previous work based on the Lenovo ThinkVision 27-inch eye tracking based light field display, which already have been launched in the market. We can see the different angles of another person when moving. Okay, this is our current work. Based on the multi-person viewing Lenovo light field display. It is the real virtual fusion and can see the different angles of another person and the avatar when we moving from the display and for the multi-person viewing. Okay, next is the component of our system. Our camera area is used consists of nine Basla cameras. the captured video and transmitted to the Lenovo Sync Station PX via USB and synchronized use a signal generator. The entire process pipeline runs on the GPU memory. Viewport CCS is handled by two RTX 49 GPU, and as tasks are executed on RTX 50,000 ADA GPU. The displays use Lenovo 65-inch 8K light field screen. This is the pipeline of our system. Capture the video and do the image correction. Then semantic segmentation. We got nine multi-human images. Oh, okay.
Hi, I like a hot caramel macchiato, tall.
Okay. Anything else for you?
No, thank you.
Perfect. I'll see you doing it by 25.
Adrian, can you please mute yourself? Thank you.
Okay. I will continue.
Yeah, please continue.
Okay. And feed it to our new viewport synthesis algorithm and to generate the 50 new views and feed it to the virtual fusion module. Then the auto-scrub 3D reading display our light field display. About the human video capture, we first use the image correction. It is achieved by allowing image plane of the camera array according to the perspective transformation. Then go through the RVM segmentation model to process it. We use optimized RVM and CUDA to utilize the system performance. In the new viewport synthesis model, we optimize the network and use C++ to accelerate it, and the feature extraction model to extract pictures to source viewpoint. With this improvement, the system synthesizes 50 new views in 35 milliseconds. We built a virtual capture based on the Unity, simulating completing the 50 viewpoint virtual screen capture. We use a synthesis algorithm to fuse the multi-view portrait image, multi-view virtual foreground image, and the multi-view background image to multi-view virtual real field images. Finally, we can support simulated viewing by multiple people, and the system and the frame rate can reach 20 FPS. And shown in the figure, our final presentation effect is a combination of a real and the virtual. The real person, the virtual character, the virtual background are all presented by the system. Viewed can see different content from different angles. About next step, first we will integrate our compression and transport platform and build a bidirectional communication system with our work. And another, we will use a higher resolution and a bigger size multi-person viewing light field display to achieve more immersive 3D experience. Finally, we will add the real virtual interaction to our system. Using ghost splitting to real-time reconstruction the person and fusion with the pre-built ghost splitting represent the virtual basic and environment, then do the real virtual fusion to achieve this goal. Thanks.
Thank you, Zilong. Any questions or comments?
Hello. Great talk. Thank you. So my question is, you mentioned that you are going to look into Gaussian splatting for virtual reconstruction. I'm wondering, have you guys looked into nerfs? And like, do you think like nerfs will be fast enough for what you guys want to do? Thank you.
We already do some work on nerf, but nerf is not quickly enough to do the real-time reconstruction because we have to real-time reconstruct the person. The environment and pre-built, maybe we could use nerf, but we can now we find it we cannot use nerf to real-time reconstruct the person. And because we want to do them real virtual interaction, ghost splitting representation is more easy to use when we do this task.
Hello, I have another question. So you showed
okay.
the purpose of this for like watching one person from multiple points of view. Have you thought about using it for like live sports or theater to showcase something like that from multiple points of view and try to give more than just a planar experience?
And the screen size limit, and now next step we will use the 110-inch screen. And in the theater, the solution is not ready. We think first the size and the resolution limit. But I think in the future maybe that's possible.